You gotta, no wait, okay. No. Hey, this is PJ 1.1. Position and constant velocity. Here we see some guy walking with constant velocity towards another point from the origin. His position can be plotted against time.
Alright, as we see right now, Oliver is at position 0. He will now walk along our magical ruler to position 3. Right there, Oliver. Now, if we want to find out what was his velocity over this time, we can take his change in position, which was 3, and divide it by 2 time intervals, giving us his total velocity over that time period. Now, let's have him go back. Now there he goes, all the way back to the start. Now, his displacement totally is 0 after this whole interval because he went forward 3, but ended where he started. However, he came back slightly slower than he did when he started walking out, meaning his velocity was less, meaning in a graph, it would come steep, flat. Yeah, that's good.
Aiden, no.
Go.
Wow, that's awesome.
Now, as you can see, Taran's position was not uniformly changing, but his velocity was. That means he has a constant acceleration. But if you want to find the average acceleration between any point on the graph, you have to find 2 points very close to each other, take the average acceleration over those, and then divide it by time.
Now what is a meter per second squared? Well, I call that acceleration.
Go.
Now what have we just witnessed? A classic physics stunt or something greater? Constant acceleration due to gravity. The mass accelerates down at a constant velocity of 9.8 meters per second, or the gravitational constant.
Now what about average acceleration? You see, acceleration. Now what about average acceleration? Now what about average acceleration? You see, average acceleration. What about average acceleration? You see, acceleration is the slope of a velocity graph, which is the rise over the run, or v final minus v initial over t final versus t initial, or delta v over delta t. Yeah.
Now let's put that all together.
Here, we see Taran walking at constant velocity. Then, we're going to see another type of movement. He's going to tag Cole, and he's going to start going. He's speeding up, stopping. It's an example of not very constant velocity, but we can actually get his displacement over that area over time, and that'll be his average velocity. Now he's going to tag Oliver, and we're going to see an example of constant acceleration, where he jumps down and then hits the ground. Go again.
Good enough. Go.
Go.
Yeah, you told me to act like
Go.
it smells awful.
Go.
Now what about average acceleration?
Fuck.